integration and volumes of revolution. In this graph, the shaded region is bound between the line y equals x, the y-axis here, and the line y is equal to 2 here. Now if we take this area, this shaded area, and rotate this one complete turn, so 360 degrees around the x-axis, you generate a volume, and the three-dimensional object that you get will be a cone. So watch what happens here. Can you see this area being rotated is generating a 3D object, and it's complete. That's one complete turn around the x-axis, and just spinning this round you should be able to see a cone. So if you take any area and rotate it around either the x or the y-axis, you end up with a solid object. And you can work out the volume of this solid object using integration. Now this is the standard formula for rotating an area around the x-axis. So pi y squared dx. The limits here will be the values from the x-axis. So from my example here, the limits would have been x is equal to 0 and x is equal to 2. Now because we're integrating with respect to x, it's the x terms that you're going to integrate. So this at the moment says y squared, so we need to replace y with a function of x. That's quite easily done. Typically you're given the equation of the line or the curve here, and that's in the form y is equal to something, and to get it into the form y squared is equal to something, you just square both sides of the equation and you'll have what y squared is equal to, and that's easy to replace. Now you can also rotate an area around the y-axis. In that case, your formula is this, so pi x squared dy, and this time you will have limits here along the y-axis, y limits, and in the formula you've got x squared, so you need to replace the x squared with some function of y. Again, that's quite easily done. What you'll see with both formulae is you've got opposites here, so if that says y there, you've got x here, if that says x, you've got y here. That might help you to memorize these. Okay, let's have a look at an example. Now, this is the one that you've already seen about the cone. So the area under the graph y equals x between these limits is rotated one complete turn around the x-axis. That forms a solid shape. So there's the area that we're going to rotate one complete turn around the x-axis. So start off by writing down the standard formula. That's for rotation around the x-axis. That says x, that says dx. That's a good way of remembering this. I've got the limits, 0 and 2, that's along the x-axis. There's the pi, and we need to replace the y squared with some function of x. We know that y equals x in this example, so y squared will be equal to x squared. Okay, so y equals x, so y squared is equal to x squared. So that y squared has been replaced. using this with x squared. And that's simple to integrate. Gives you x cubed over 3, put the limits in, and then simplify. So this is the volume generated when this region was rotated. And as you can see, there's a cone building up here. It's being rotated around, the area is being rotated around the x-axis. There you go. So the volume of this three-dimensional cone here is 8/3 pi. That's the exact volume. And you can use this method to work out the volumes of some standard shapes, like a sphere, for instance. A sphere is based on a circle. If you take a circle and rotate it around the x or the y axis, you can show that you get 4/3 pi r cubed, which is the volume of a sphere. That's quite easily done. Okay, moving on. In this example, we're going to look at, again, rotating an area, but this time around the y-axis. So you can see from the sketch, it's this shaded region here that's going to be rotated, and it's a rotation of 360 degrees, or 2 pi radians, around the y-axis. The area here is bound between the curve y equals x cubed and these two horizontal lines here, so y equals 1, y equals 8, and this region is going to be rotated, so we need the standard formula here, and in here the limits there and there would be 1 and 8. So we've got this. We know we need to replace the x squared with some function of y. Because that says dy, we're going to be integrating terms with respect to y. The equation of this curve is y equals x cubed. So we need to rearrange this. So we've got x squared is equal to something. So I'm going to start off by trying to make the power there, the 3, make that into 1. To make x to the power of 1 on the right hand side, if I raise both sides to the power of 1/3 to begin with, so we've got y to the power of 1/3, raising the left hand side to the power of 1/3, doing the same to the right hand side. And as you can see from here, the power on power rule, 3 times 1/3 is 1, so you've just got x to the power of 1. So x is equal to y to the power of 1/3. But in the formula, what we have here is x squared. So now I'm going to square both sides. So x squared is equal to y to the power of, and if you square y to the power of 1/3, you get y to the power of 2/3. Because it's like this. You've got this, squaring it, power on power rule means you multiply these, that'll give you the 2/3 there. Okay, so that's given us this. So we've got y to the power of 2/3 here now, instead of the x squared. From here onwards, it's just straightforward, integrate, put the limits in. There's nothing more to it. So I've integrated here, and I'm going to put the limits in next, here, and then simplify there. So that's the volume that you get when you rotate that shaded region around the y-axis. And look out for questions that say work out the exact volume. So don't give a decimal value here from your calculator. When the question is asking for the exact volume, what they mean is give the volume in terms of pi.